Hello, everybody. Thank you for inviting me. It's a very pleasure for me to participate in this very interesting event, and I think it's really an event in my mind because I think it's a very key information for the Italian people in general, and I think so. I'm very happy to be here, and I will talk about the Italian Space Agency, which is the company from where I came from, and I try to give you some inspiration for your future work. I like I'm a movie enthusiast, so I start from these two movies that maybe the first one no one of you ever ever seen in the past, because it's 1968 film, so it's a 2001 A Space Odyssey, and it's talking these two movies are related to artificial intelligence and space in my mind. The first one is, of course, because an evil artificial intelligence that's trying to kill people. It's a very good film. I suggest to looking at this film if no one knows it. And the other one is a very recent film, which is 2021, Don't Look Up, which is about an asteroid in collision orbit with the Earth. Why I put these two pictures here? Because in the first case, we have an artificial intelligence trying to kill people. And the second one, I think that the artificial intelligence could help saving the planet Earth in this case. We will see this in a specific project that I will talk about in the next slide. So go ahead. Okay. So, some words about the Italian Space Agency. The Italian Space Agency is born in 1988. It's a public institution, so it's funded by public money. The true Italian Space Agency, Italy is the third contributing partner to the ESA budget. The ESA is the European Space Agency that you may already know, which is the funding agency for mostly every space mission for space exploration and Earth observation. So Italian Space Agency is supporting the science community in this kind of effort for the general research. Another project that I have to mention is the space propulsion research with the Vega program. That it's an original program that the Italian Space Agency is funding. Just a word about the fact that the Vega program is the third propulsion system existing for Europe, for the European space missions. The first one, of course, is the Ariane space propulsion system. The second one is the Soyuz Russian propulsion system, and the third one is a totally Italian program, which is based on the Italian industry. And so I think it's a very key aspect of the general space economy for the Italian institutions. ASI is in the middle between research and application, we can say, because of course we support the research, but we also want to foster the application of the research. So in this sense, ASI must be aware of both these aspects and must contribute to both aspects. And this is not so common in other institutions, or at least in Italian institutions. So I think this must be considered. About the field where ASI is involved, we talk about research. So some of the hot topics are gravitational waves, exoplanets, gamma ray bursts. About application, we have, you may know about the International Space Station, which is where the Italian Space Agency has a very strong contribution, and also the space control, the command control of the Italian Space Station is Italian, and it's followed by Italian personnel. And then for about development, we have some prototype which is about space weather, which is called ASPIS, which is a new project starting in this days. And about services, we have Cosmos SkyMet, which is a satellite constellation of satellites for the Earth observation, which is a very strong program followed by ASI. And then the Space Italiana Data Center, which is the center where I come from, which is the data center for the space mission, which is based in Rome, and that is hosting every space derived data coming from space exploration, and also for Earth exploration. Finally, I have to mention some of the main mission we are currently supporting, which is the ExoMars for Mars exploration, the Juno mission for Jupiter, and XPay, which is a mission about X-ray analysis. Finally, last but not least, the economic exploitation, which is a key field where the ASI is working, which is where ASI is trying to foster the economic development of what we call the space economy, which is a field very fastly growing in the last year. So I think that everyone who want to be involved in the space economy must consider the fact that this is a very very fastly increasing field. So in this case, for this audience, of course, as you may know, it will be very easy to find jobs and to find position for this kind of field, economic field. So about space and artificial intelligence, here you see a sample picture. From the left one is from 1965 from the Mariner spacecraft, and the right one is from HiRISE, which is another probe, and both are targeted at Mars. And as you can see, the resolution of the image is very different in both cases. Why I show you this picture? Because of course, as you may imagine, science instruments used in a space mission are rapidly and are evolved in a very rapid way in the last decades, and so such instruments are capable of producing a very large volume of data, as you can imagine. This increase is exponential. So how the science research based on this kind of data is evolving together with this increase? This is a very not an easy task, because a lot of data in most cases requires very time spending for science analysis, for software programming, and for decision making about which kind of, for example, which kind of target must be focused by a space mission, and also a very limited resources in doing this kind of tasks. So why? Which is a possible answer to this kind of difficulty? One kind of possibility is inserting the AI in the loop. So what we can observe in the last years is that this traditional science production process of the science community is changing, and is going to use the AI algorithm, AI instrument, AI techniques to exploit the science return of the data coming from the mission, because just only the human brain is going to have is coming in a very difficulty, let's say hard work, because a lot of data requires, as I say, a lot of time normally. So in this case, we see this change in the paradigm of science production, which is very interesting cultural change. And so this is, I'm speaking about this because, as you can imagine, the outcome of this change is the heavy use of AI, also in the field where they weren't used just some years ago. So a simple example about for just to give you an idea is the Gaia mission, which is a mission charting the 3D map of the galaxy. So charting all the objects visible from this instrument, which is a probe outside space probe. So it's observing all the stars in our galaxy. And as you can see on the left, you see that the count of objects observed are 1,006,007,000 million objects. So in this case, as you can imagine, the cross relation, for example, of this object with already existing catalogs is a very hard task. And so this is just an example of what we call the big data problem. So about if we talk about machine learning, which is the hot topic right now in the artificial intelligence field, just a word about what we see as the most interesting technique inside the deep learning fields, which are the GAN network, which are the generative adversarial network. They are mainly used for the task you see here, which are image classification, image reconstruction, and data translation. This you will find a lot of example, a lot of publication about this, because this kind of deep learning technique is that is used to generate what we call synthetic data, so fake data produced to be used for scientific purposes in general. And this kind of techniques is I pointed out for this audience to keep in touch with this kind of technique, because it's very used in for remote sensing, which is the typical task used by probes and space probes by observing some target in the universe. To go with a real example, I want to talk to you about a single mission, which is a double mission, really, because you see here both the logo of ESA and NASA. This is why the meaning of this both agency is that they are both involved in this mission. The DART mission is a NASA mission, which is, as you see on the right, which has been already launched in 2021 and is currently going to impact in this year, late in this year, through an is going to impact through an asteroid. And you see here the timeline of the mission, and as you can see, there will be different phases. The first phase is the NASA mission called DART that is going to impact the asteroid and trying to deflect this asteroid you see here, which is called Dimorphos. And then has a mission launched in 2024, will be launched and will observe the effect of the impact. So 2 years after the impact of the DART probe. This is a very interesting mission, I think. So I'm talking this, I'm explaining this mission because there are some artificial intelligence related tasks that will be specifically involved in this mission. As you can imagine, this is a planetary defense mission. So the purpose of this mission is to trying to analyze the effect of an impact on an asteroid, which is called Dimorphos. But as you can imagine, the first probe will impact the asteroid and will be completely destroyed by this impact. So then the second mission, which is an ESA mission, so the Hera mission, will come later and observe the effect of this impact. The effect, of course, will be, beside the crater, will be a change of the orbit of the asteroid. So why I'm talking about this mission? I'm showing you a short video that I think is interesting to see about this. I hope you listen to the music and.
Yeah, we can hear. Thank you.
Okay. Okay. So as you've seen already in the video, why the artificial intelligence is involved in this case? Because one of the tasks of this mission, the Hera mission, so the second part of the mission, will try to demonstrate the possibility for autonomous close proximity navigation, and close we intend here less than 88 kilometers, when the probe will be very near to the asteroid where the impact has already occurred, and we'll try to calculate its exact position in the space only through the computer vision techniques. So looking at an unknown body, unknown just until the probe arrives near the surface. Of course, this is an unknown body, so it was never observed before. So of course, the images coming to the imaging camera that you see on the right will be the first images at this resolution coming to the instrument and then to the ground. But of course, this will be an autonomous navigation that the probe must be able to perform. So in this very short video, you see what will happen. This is just a simulation. What will be performed during this close approach, And so the probe will try to map the feature of the surface of this target, and trying to use these features that you see to calculate the exact position in the space, and trying to navigate autonomously in a desired position with respect with the asteroid. So I think this is an interesting application of the computer vision technique. And in this case, it's a very challenging task, as you can imagine. One other another task that will be performed during the mission will be the hyperspectral image demosaicing. So in this case, maybe you're not familiar with this kind of problem, but in short terms, it depends from the kind of detector that you will use to observe this target, the asteroid. And this you see on the right the detector, which is an hyperspectral detector, where each pixel can acquire a single spectral channel. So in this case, there is a problem called mosaicing that must be resolved through demosaicing, which is related to trying to reconstruct a full hyperspectral image of the target by filling the gaps between each pixel and the next one, trying to reconstruct all the spectra through all the pixels, because each pixel see only one channel, as you can imagine, as it is implemented. So in this case, it will be used a realistic data set of images through a simulation through the university that is involved in this task, and this data set of images will be used to train a neural network that will be used for calibration of the images once they will come to ground. So I think I've run out of time, so I'll go ahead very quickly. I know I don't have all the time to give you all the details, but anyway, I'm here for any questions. And last task is about a task that we are already performing at ASI. It is about the use case related to computer vision, again, applied to boost detection and the classification of the white ovals, which are the object observed on the Jupiter surface, in the Jupiter atmosphere, you see on the left picture. And this is an algorithm, a technique used to detect and classify these white ovals, which are cyclones or anticyclones in the Jupiter atmosphere. This was a technique defined by my colleagues. All the details have been presented in the European Planetary Science Congress. You see here a sample image acquired from the GIRAM spectrometer on board the Juno mission. So this technique is based on this, as I said, in a computer vision technique based on finding the best colorimetric and spatial features to extract cyclones and anticyclones from the background, from the noisy background. So starting from this kind of image, where the original image has been filtered by a priori knowledge of the existing compound into the Jupiter atmosphere, we defined 3 different images, and then applied a set of technique based on color constancy and automatic image mapping. We produced these 3 derived images, where you can see that the feature related to cyclones and anticyclones are well defined with different features, both spatial, topological relationships, shape, orientation, and so on. So at the end, the white ovals have been detected and classified in a very precise and very accurate, with very accurate results. This technique can be, of course, applied to any other kind of mission, any kind of target, any kind of celestial body in general. Sorry for being a little long for my presentation. Of course, you can contact me at this mail, and I encourage you to contact me. We are ready to create any collaboration with any people interested about this kind of task that we are currently working on. And so, thank you, and thank you again for inviting us here at this Congress. Thank you.